Hi guys, welcome to section 9.6b. This is the last section in chapter 9 for algebra. Our objective today is to find solutions for systems of equations. They could be linear, they could be nonlinear. Think back to section 9.6a where we did linear, quadratic, and exponential. We did do solutions to a system way back in the first semester when we had two lines. And I remember graphing them and looking for any point where the graphs intersect. So a solution is where graphs cross each other. Remember, the graph is the actual line or parabola or exponential that we're graphing. So it's not the graph itself, but where do those guys cross or intersect? So to find the solutions, short little three-word thing here, graph each equation. So remember, you're going to need to check to see if it's linear, quadratic, or exponential. We know how to graph linear equations, y equals mx plus b, find the slope, use the y-intercept. We know how to graph quadratic equations. We can find the vertex, we can find solutions, the y-intercept. We know how to graph exponential, and the only way we can graph exponential is using an xy table. So make yourself a little note about that. You need to have at least 5 points for each graph. So that means on each graph, when you've got two different equations, you're going to have 10 points. Finish one and connect the dots before you go on to the next. After you've graphed your equations, mix and match of what type they might be, then you're going to look for your points of intersection. Those are your solutions, and they're going to be actual ordered pairs like X, Y, and A, B, or something like that. So they are actual points, X, Y, ordered pairs. All right, so not much to talk about. Let's just do an example or two and make sure you've got this. So my first practice problem, notice here's my system. I've got y equals x squared, and I've got y equals negative x plus 2. I'm going to put both of those graphs on the same coordinate plane. I'm willing to bet you can tell me just by looking at this y equals x squared what kind of graph it is. Its highest exponent is 2. When we graph it, that's a quadratic or it's going to be a parabola. Notice I even gave you the hint here by finding the axis of symmetry. Axis of symmetry, x equals negative b over 2a. All this comes flooding back. So it looks to me like my a is 1, my b is 0, and my c is also 0. So my axis of symmetry would be negative 0 over 2 times 1, or 0. I also know then that that means the first half of my vertex is 0. When I plug that in, I get 0 squared. Not a whole lot of information. If I factored this, I'd get x equals 0. My y-intercept is 0. So at this point, all I've got is that vertex. You probably could tell me if that parabola opens up or down. Hopefully you know. But in order to get at least 5 points, I'm going to have to go to my xy table. Remember, put your vertex in the middle and then count in each direction to make your life a little bit easier. We should see that symmetry, so it should make things happen very nicely. So if I put a negative 2 back into my original equation, y equals x squared, what is negative 2 squared? We've talked about this negative thing before. Comes out to a positive 4 because negative 2 times negative 2. Negative 1 squared will give me a positive 1. Positive 1 squared is 1. And positive 2 squared is 4. So now I've got myself 5 ordered pairs. The vertex is already on there. I'm going to put the rest of my ordered pairs on this graph. And I'm going to connect those dots to make myself a nice parabola. Kind of missed that point a little bit. Maybe I should fix that. The other thing that we need to graph is what kind of equation is y equals negative x plus 2? Well, that's linear, right? So we can do our m and our b, y equals mx plus b. So what is the slope of this equation, or the m value? -1 or -1 over 1 if you prefer. What's the b or the y-intercept? The really nice thing about lines is we don't need to go to an xy table if we know the y-intercept is at 2. And we know that our slope is -1 over 1. Remember, that's rise over run. So I'm going to go down 1 and right 1. Do you remember doing this graphing from back in the day? Down 1 and right 1, down 1 and right 1. Because that point's right in the middle of the parabola, I'm going to go in the opposite direction. So I'm going to go up 1 and left 1. And hopefully you've got some fire alarms going off in your head, because if we're looking for solutions in ordered pair format, I see that my two graphs intersect in two places. So right here is one solution, and right here is my other solution. All I need to do is put those into x's and y's. So to get to this point that's farther to the left, it looks like I go back 2 and up 4, so -2, 4. This point that's farther to the right, it looks like I go over 1 and up 1. So there are my solutions based on my parabola and line that all got graphed on one big graph. It's a lot of work and it's a lot of remembering. So that's why we've only got 2 problems on here. Let's do an example so you've got one for our second system. Our y equals 2 to the x power, and then y equals 2x. So first things first, is that y equals 2 to the x, is that linear, quadratic, or exponential? Our highest exponent is an x. Remember we said quadratic, our highest exponent was a 2. So automatically, exponent with the variable, this is an exponential. The only thing that we could do for an exponential, spelling it wrong, is to make that xy table, and I do -2 to +2. So you might want to go to your calculator because you're going to get a decimal. If I put -2, don't forget that that's an exponent. So when you go to your calculator, you're going to do 2 to the power of -2, which comes out to a 1/4 or a 0.25. Use a decimal or a fraction, whatever's easiest to put on the graph for you. When I do 2 to the power of -1, I got a 0.5 or a 1/2. Hopefully everybody remembers what 2 to the 0 power is. Go to your calculator and try it, and no, it's not 0. Anything to the 0 is 1. That's that trick problem. 2 to the first power is just 2, and 2 squared is 4. Hard part's done. Let's just get these points on my graph. So -2 up a little bit, a quarter. -1 up a half. 0 up 1, over 1 up 2, and over 2 up 4. So here is my exponential graph. Is that exponential growth or exponential decay? Absolutely growth, right? Second equation, y equals 2x. Is y equals 2x linear, quadratic, or exponential? What's your highest power on your exponent? 2x to the first power, right? So that's just going to be a straight up linear equation. So your job is to finish y equals 2x. Look for your slope and look for your b. Remember, y equals mx plus b. If there's nothing there, you probably know what to put. Graph that. And then in the practice problem, I'm going to ask you to write your solutions for this problem. So we've got an example of a line, an exponential growth, and a quadratic. So we should be able to get those things on the graphs, finish this line up. So here's what I want to know. How do you tell the difference between a linear, a quadratic, or an exponential equation? So if I give you the equation, not a table like in the last section, but an equation, what are you looking for? How do you know? If you know that, you're starting off one step ahead because you actually know what your graph should look like. And then, like I mentioned, finish practice number 2, graphing that y equals 2x. Write your solutions in the practice problem box. I'll be looking for those, guys. Have a great day, and we will see you next time.